welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, I'm the host of House of ZK. I'm joined here today with our guest, David, who is a creator of Gonka protocol. And this is, yes, thank you so much, David, for joining. This is a continuation of our conversation with Daniel back at House of ZK's Verifying Intelligence event at Token 2049 Singapore. But this time we're joined here today with David, who will talk more about the technicalities behind Gonka. So I'm very excited for this, and thank you again, David, so much for joining.
Thank you for having me.
Yeah, thank you. I just wanted to start off with just the origin story behind you and your siblings founding all of these different tech-related ventures. I know for the past two decades, you guys have founded quite a bit and even did some work at AR with Snap. So do you have any kinds of or takeaways from the experience in terms of, for example, your time at Product Science and Humanism, and even starting the Quantum Biology Center? Do you have any takeaways from all of these experiences in terms of the direction that you see tech should go into, as well as maybe during the process, how your relationship with working with each other, with your siblings, have evolved over time, and what you guys hope to see developed in the next 30 years or so?
Sure. All great subjects. So, hey, I'm David Liberman, creator of Gonka, one of those siblings, Liberman brothers sisters. We built companies together since our high school years. So our story starts with our parents. Our parents both worked together as one of the most known biophysicists back in Soviet Union. So I think that because they work together, we kind of haven't developed the concept that relatives shouldn't work together. On the opposite side, we always were inspired by their work. And when we were kids, we got quite early access to personal computers in our apartments, much earlier than most of the peers because of the science background of our parents. And it was pre-games, so we started to be excited about technologies without having the beautiful, colorful picture, but just from the pure perspective how it can change lives. And when we were in high school, we started our first company. It was just actually desire to have better internet connection, and it was super unaffordable. So we got through all our neighbors, and Moscow is quite dense city. So it was eventually 1,500 households we connected to internet, and the entire initiatives was quite decentralized. When our clients were also builders of the network, so everyone kind of joined forces to make this project happen. And still building this network, starting some first chats over this network, also showed us how this all can be an enabler for freedom and for general progress. So our next project after that actually was in the field of distributed compute. It was like pre-blockchain. It wasn't something with a good financial model, but just an idea that computers around the world can connect, and that this network can be quite powerful. At that moment, we actually managed to connect couple 100,000 users, and the power of this network was 10,000 teraflops. I still remember this number. And yes, now it can fit to just one NVIDIA GPU, but by that time, it was a power bigger than the most powerful supercomputer of that time. Imagine that just students created something so powerful just because of decentralization. And since then, we were quite fascinated about what is coming in and how this type of technology can be an alternative to centralized players and their business models. So since then, we built multiple companies, mainly in applying machine learning. Now everyone called this AI, but it's actually by that time the main term was machine learning. So we applied it to various different tasks like games, animation. Animation studio was quite a success for us. So we applied those models to make animation production much faster. And still, it was a lot of, we learned a lot from the decentralized compute, how we should build our cluster servers in a quite a different way than most of the studios at that time believe it should be built. Not like one storage for all those servers, but actually decentralized storage over our office compute and things like that. So we developed this passion for those technologies through this time. And at the same time, still a little bit because of the background of our parents worked on the problem of consciousness, how actually in biology it emerged. So our uncle is Michael Bongard, who was quite early in describing the future neural nets and how they will work. So we used all this background and applied it for different applications, and eventually we moved to California and built multiple ventures in the United States. One of these was focused on AR, as you mentioned, and we sold this company to Snapchat, building avatars. If you ever use Snapchat, you see in most of the screen, you see this beautiful avatars, which we created. It's still one of the most used avatars. So through that prism, I think that what we learned together as a team is not only how to make technologies efficient, but also how to make the product out of it, which people will enjoy and people will love, and how to make something viral. So this is kind of background. So after that, we built also, when we exit Snap, we built multiple ventures. The capital which we acquired through this sale, we invested in many directions which we really love and want to see more in the world. One of this was quantum biology laboratory based on our parents' scientific work. Another one was pure AI company product science. We worked with most of the big names in the US, like JP Morgan Chase, one of the biggest banks, Walmart, one of the biggest retail chain, Airbnb, you all probably know. And we built AI tools for coding for those organizations. And we started it a little bit before ChatGPT was released. And when ChatGPT was released, it was definitely an acceleration moment for anyone involved in AI. And for us, it was an exciting moment. At last, this all happening, the intelligence, productivity will grow so fast because of those technologies. But also, it was a moment of fear, I would say, with that speed, those technologies can develop in the way so that it won't be as beneficial for humanity as a whole. And you likely heard a lot about AI safety. Yes. Even the creator of ChatGPT left, the Elias Utzkever left OpenAI to build safe superintelligence, and he is one of the most known scientists developing this idea that we need to think about safety. And for us, having this background of building decentralized compute, for us, safety, the only way for safety was always decentralization. And that's how Gonka as an idea emerged. We decided that we need to put all the efforts possible to make the future of AI decentralized. And this is our big mission right now. And also we see a lot of great teams in the sector, which right now push forward this idea. I think we will all work together against of what we all see with big companies having most of the power in a field, and we should use any chance for a different future for all of us.
Yeah, got it. And thank you so much for that whole story. And I really enjoyed hearing how one of your first projects were decentralized in nature, and all the clients were builders of the network, and you saw it as an enabler for, you mentioned, freedom and genuine progress. And even for your second project on distributed compute, it's very impressive what you have achieved out of that. And after all of these years with building decentralized and distributed compute for these servers, for these systems, you're now applying it to how we can make AI more safe. So really liked that journey that you described. And I wanted to go more into the idea of safety in AI. And you mentioned that you see one of the ways of doing this is building this based on decentralized compute and not having all of these big companies have all of this compute or have it be centralized to them. So I wanted to hear more about what safety in AI really entails and how you see it, and then also the need for making AI more decentralized, especially for, say, model training or inference for some models, and how it compares to, say, using those centralized cloud providers, especially you mentioned like some consequences of having these big companies having all of this compute. I'm thinking in terms of, say, like high costs with monopolistic pricing, or even maybe some censorship or centralized control issues. So I wanted to hear more about just the need for safety in AI, what that entails, and where decentralized AI can come in.
Yes, when you hear about AI safety, you would usually hear about a killer switch. Say, like, if we build this super intelligence, which will be way smarter than the human being, and they can make decisions, not really good decisions in terms of our future. We've seen many movies about that. And most of the AI safety scientists would say that we need to have this killer switch. We need to just be able to turn this super intelligence off. First of all, imagine that you are this super intelligence, and someone has a killer switch against you. What would you do? You most likely will destroy this this less intelligent species, which really want to make you killed. And moreover, this idea that you actually can control and that you actually can have the leash, it is as soon as you really will get through this line of thoughts, and you will really imagine this super intelligence, you will realize that it is not possible. This is kind of dead end. In this scenario, we rather should be peaceful and not try to make any harm to this creature. But another way for safety is to have not just one super intelligence, but billions of AIs. in this case, there won't be any AI too powerful to dominate and to make harm for most of us. For example, one of the scenario described in the subject of AI safety is that what if AI will just try to trade on stock exchange and will just crash the entire market, profiting from our negligence and our ability, slow ability in terms of predicting the future compared to the super intelligence. What will happen then? And in this scenario, if you imagine that there is just one huge super intelligence in this super cluster like Colossus of Elon Musk or Stargate of OpenAI, in this case, yes, we will are in troubles. But as soon as you see a future differently, when multiple AIs with different alignments out there, none of particular AI will be able to actually crash the market, because as soon as it will try, other AIs will play against this this bad AI and will just squeeze all the capital from this attacker. We've seen it many times. We see it in decentralized system, how a consensus making in the ability to rely on this ideas that most of the participants are honest, and just we need to be able to stop the small amount of attackers from conquering the network. All like Bitcoin is built on this idea. Like most of the blockchain projects are built on this idea. And that's why we believe that decentralization is important. We see that in this future we need to see many players. Some of them will have their own consciousness and their own intelligence. Some of them will be pure tools for all of us to supercharge our abilities as well. You know, like when we think about the super intelligence, people usually compare it with ourselves as we are right now, and it is quite bad news for humanity. Like we would be dumb compared to those structures. But as soon as you will think about yourself as an individual empowered by not so conscious AI, but still super powerful and super smart, it's not as bad of a story. So what's important is to also make it not only decentralized. Many agents, many actors should be involved, but at the same time, it should be affordable. So each of us will be able to use the maximum power of AI. Like if you're an engineer, you need to have access to the full power and knowledge of models to create products better. Or if you content creator, is the same. You need to have full power. Not Meta or OpenAI should have this power, because at some moment they will definitely all forget about creators and they will just generate the content. But if all of us will have the access to the tools, none of the centralized players will be able to control the distribution and control the future of the markets.
Yeah, got it. So we want to avoid a future where we have just one super intelligence that can dominate everything, but instead we want to have multiple players, multiple AIs with different alignments that can enforce these checks and balances against one another. And at the same time, keeping the use of AI affordable, and anyone who needs them. You mentioned, for example, content creators to engineers can have access to it. And we've seen at least case studies of the use or the interactions within these decentralized systems. And for example, Bitcoin was one of the earliest, at least in the crypto space, to adopt the idea of decentralization. But hoping to see that we can have more of these structures be enforced in in our everyday lives. So those are some great points that you mentioned. And to that point, I also wanted to ask you more about our current status quo when it comes to our centralized systems in terms of lack of transparency that we're seeing and also lack of control as well. Even, for example, with the withdrawing or the replacement of some models, I remember, was it GPT-4
Or
Mini, I believe, yes, that got replaced for a bit, and that received a kind of a lot of backlash from a lot of users who really loved that model. Just curious to hear more about some of these caveats that we currently see when it comes to how these centralized systems operate with AI, and what does network consensus enable in terms of building trust in AI, especially if we get to that point where models aren't able to be altered or retired just from the decision of like a single provider. What would that look like?
yeah, so we've all seen that. Like when OpenAI was created, it was created with the idea that it would be really bad for humanity if Google will dominate AI. They had the same kind of intention as I described, and they realized that the only way to make it happen is actually to be a non-profit and to be open source, like open AI. They published every step along this path. But as soon as they become the dominant player, they change that. They stop being so open, and they actually become the thing which they all was originally afraid of. And from this perspective, we can definitely learn a lot from this process. And what's important about Bitcoin, Bitcoin wasn't the first decentralized project. Before that, BitTorrent was the most powerful storage network of this time. Most of the people remember it as piracy, but actually BitTorrent started from IBM using it to distribute their Linux images. So because they were too large, and it was really hard to sustain the servers which will distribute these images. But Bitcoin invented the financial model for that, because before that, still the financial part of decentralized project or open source project, they were shaky. Yes, we have Linux, which right now dominates the market, but still, the community was struggling in terms of attracting the capital and making the growth even more pronounced with the resources which this capital can bring. And Bitcoin enabled that and showed that there is a path for open source to actually accumulate power comparable with the biggest players out there. So we do believe that we need to learn a lot from this experience, and we also, I don't think that those centralized players are bad. They actually invest a lot in develop the underlying science in a way which we all can enjoy right now, but we definitely need to make everything as possible so that this power will not concentrate too much. Because even if there are like really good intentions out there, we do believe that there are good intentions in those companies when they develop AI and when they make different decisions, but we've seen it in the past. It's really hard to make good in the world when you have too much power in your hands. And I think that this is where decentralization in the community which builds networks like Bitcoin should step up and make a different version of reality when most of the compute is not controlled by those big players. Because you asked about status quo, like current status quo, if nothing will change, what we'll see is that those companies will control 90% of the compute. And the service which they will be able to provide to the users will be so great so that it will be really hard to switch to open projects. If you look at NVIDIA public reports, you will see that 39% of the GPUs sold to just 2 companies. And they just don't mention the other 3, which is another like 30%. From this perspective, it is quite dangerous, I would say. But at the same time, we're still quite hopeful, because even though this is a kind of main scenario right now, but the fact that this main scenario creates tension and energize right now, as we speak, millions of people to make everything possible for a different scenario to happen. What's good in this time is that we're not just kind of empowered with ideas and with passion, but also we are empowered with framework. So we need to repeat the framework, and we will see a network which will be much more significant and much more powerful than whatever centralized players can build.
Yeah, absolutely. And definitely to your point, it's really hard for the concentration of power to not happen, especially if the system itself is fundamentally centralized. So we need to go back to making the roots of the system distributed. And you mentioned even like the NVIDIA example, dedicating the majority of their compute to just a couple of companies. But really like the point you mentioned that now we aren't just empowered with like ideas in our mind, but we have these frameworks in place. We have some case studies of how distributed compute has worked in the past and how decentralized models have worked in the past. And we can now apply them to, in this case, how we manage our AI models. So really liked those points that you mentioned. But just out of curiosity, I was wondering if we could also talk about some of the trade-offs or the caveats that currently lie in how decentralized systems today are currently designed. Nowadays, a lot of people talk about some inefficiencies that these decentralized systems have in terms of, say, with how they currently struggle with allocating resources efficiently, or even with incentive alignment as well. And I know Gonka specifically is really looking into how rewards can be directed mostly towards AI computation as opposed to network security, and reallocating the rewards in that manner. So curious to hear how you see, or like what you see as the biggest missteps or still some inefficiencies that we need to address in how these decentralized ecosystems are currently approaching themselves, especially when we apply this to AI.
So we definitely see good lessons and bad lessons. We should learn from both. From bad lessons, what we should see and learn from is that most of the decentralized projects, they weren't as easy to use by developers. Filecoin, even though it's a great network, which actually accumulated 10 million terabytes. Just imagine 10 million terabytes is more than YouTube. So many beautiful projects could have been built over this network, but it's quite hard to use. It's not a simple API which you can actually plug into your software. And that's why most of this capacity is used just for random numbers to be stored. And that we've seen a lot in decentralized area. Even projects like BitTensor were quite unusable before maybe subnet shooters emerged, and they just created centralized API over quite unusable framework. And as soon as they created a simple API, immediately the usage spiked and many developers start to use. So we cannot make such a compromise. So we need to build systems which are easy to use. Like look at OpenAI. It's really easy to integrate in your applications the whole power of AI. So you can build quite a complex system and quite computer-intensive system while still providing for developers an easy to use API. And it should be for developers who not necessarily care about decentralization. It should be for all of us, any developer around the world to use, and then users of these systems to use as well. In general, like it was quite hard to use crypto even in financial field, like to open account, quite hard, and in many other from many other perspective. So another lesson which we should learn is that it is really important how we set incentives. So incentives is a core design, is a really important innovation of Bitcoin that incentive were added to this decentralized network. We've seen decentralized networks before, also with some consensuses and verifications, but here the idea that ledger is the money allowed us to thrive. But then, because of the inefficiency of Bitcoin, in terms of amount of transactions which can be performed and things like that, unfortunately, all the efforts went to staking as an alternative because it doesn't require any energy. And it's kind of promoted as an idea that it is super cheap compared to Bitcoin mining. But not really. Like, first of all, we don't build any infrastructure. And secondly, it's not cheap. You need to pay this 20% yield or 10% yield to all these stakers, so that all the rewards which could have been used to subsidize the growth of the network instead used for capital to grow. And this capital is just really, the interest of this capital is misaligned, for example, with infrastructure growth and things like that. It's quite visible still, like for example, quite visible how it worked for BitTensor. BitTensor is proof of stake system, and also another 10% is received by subnets. Interesting idea in terms of how it this financial engineering of transferring the tokens to the subnets, how it works and how it can drive the market and things like that. But eventually what we see is that from $1 billion worth of rewards issued every year, only a fraction of it goes to the infrastructure builders, hardware providers. And from this perspective, this network, which worth $8 billion, this FDV can easily drive 100,000 GPUs to join the network, but we don't see that. We see only like 6,000 GPUs connected to the subnets. This misalignment of incentives is really important. And if we really want to make something significant in AI, we definitely should change both. Like we need to make it easy to use, and to make it easy to use, we should admit the API is not something which someone else should build, because if someone else should build, it will be centralized as chutas. Chutas, like you go to api.chutas.com, it's someone controls this API. It's definitely not decentralization at all. The API should be part of the protocol. It's definitely one of the core principles which we use, for example, when we developed Gonka, but it should be a core principle for any network or protocol which emerges in this field. So if you see the domain name in the in API URL, it means that someone controls it, and if someone controls this, it means that it's not decentralization at all. And secondly, as I mentioned, we need to build incentives in the way so that it's not just financial engineering. The financial engineering is needed if the project itself is about financial tool, like for example stable coins and things like that. Maybe financial engineering is needed there, even though we've seen that most of the programmatic stable coins, they gone, and the only ones which left, they actually hold the real assets on the balance sheet. So we need to build incentives which are aligned with the future which we want to see. If we want to see the future when most of the AI compute is produced by decentralized network, we need to align incentive with this future. Otherwise, it will never happen. In what we'll see like more of meme coins rather than something which can actually compete with Microsoft's and Google's of the world.
Absolutely. And for you believe that it's kind of twofold. So one is making the developer experience more friendly. Like, for example, even just like with a simple API call that developers can very easily integrate into the application that they're building. And the second part is with the incentive alignment, especially with aligning with what we want to see in the future, and even with what we have seen with a lot of decentralized systems, all of the efforts going into staking, and this misconception there, and how Gonka wants to redefine that. So it seems like there's kind of two big areas that we should address. One is with the developer experience, making it more friendly for these developers to use, and then also with the incentive alignment part as well.
Yes.
Mm-hmm. And from here, I'm curious to hear how Gonka specifically addresses the idea of incentive alignment, especially with, I think for Gonka, you guys really emphasize on valuing these real-world computational contributions, whether it be directly to AI compute as opposed to some things relating to network security or even, like as you mentioned, staking. So how does Gonka enforce the long-term incentive alignment and make sure that there's sustainability in the long term? And I know that Gonka itself operates on this a dual incentive architecture as well. So I'd love to hear more about that.
Yeah, so as I mentioned, like we when we built this project, like we are not from Web3 field. Yes, we are from AI field. We built companies in this area. But why we decided to build a Web3 project? Because we actually are quite inspired about Bitcoin as an infrastructure project. Most of the people think about Bitcoin as a financial tool, like new type of gold and scarcity encoded. But we actually see it as an infrastructure project. If you look at it from this perspective, you will be amazed. Data centers around the world accumulatively of 26 gigawatts. It is more like, people don't think in these big numbers, but it's more than Microsoft with Azure, Google with Google Cloud, and Amazon with AWS. Even when you see big titles of OpenAI or XAI deploying 1 gigawatt of data centers packed with Blackwell chips, in the same year, Bitcoin added 5 gigawatts of data centers. So unbelievable scale. So we just need to repeat it. Like, we don't need to reinvent anything. We just need to repeat it, but for AI compute. Also, what we should learn from this, and I think that this is where we can actually outcompete the centralized players, that if you look at what centralized players do, they all right now do this circular structure when NVIDIA invests, and then they buy NVIDIA chips, and they in all this like Oracle and involved. But what they actually do, they buy existing hardware. They buy Blackwells and spend most of the money right now to acquire those computational hardware. But it is actually a bad idea because this hardware should be obsolete in a couple of years. And you see in the reports that they are going to amortize it for 6 years. How you can amortize for 6 years something which should be thrown away like in a couple of years, because it will be too slow and too energy consuming. We've seen it in Bitcoin. Bitcoin still like showed us the past with ASICs. Yes, it started with GPUs. And originally, those who mined with GPUs, they earned a lot. It was just couple thousand GPUs in gamers GPUs, and they each earned 1,000 Bitcoins. So now it's like $100 million. So those innovators, those early adopters, they were rewarded for the contribution, but quite fast. GPUs weren't really players anymore, because better hardware, which come from not big players like NVIDIA, but smaller research facilities, who invented just better hardware for the compute, much better hardware, 300,000 times better hardware through 15 years. So we need to see that, and if we will be able to repeat this path, we will see decentralized network not as a fraction of global market, but as the biggest compute power in the world, like Bitcoin is the biggest compute power in the world right now. So for that, we need proof of compute, proof of work, in the same way as Bitcoin. Why? Because when you align the incentives with the better hardware, like proof of work does, you drive this innovation forward. But first we need to create proof of work, which will support the hardware which can run these big AI models. So hash function of Bitcoin doesn't work. It can do, like the ASICs for Bitcoin can do nothing for AI. But similar approach can be applied to create hardware which will be much better in AI compute than NVIDIA Blackwells. And for that, we need to have proof of work which will be transformer based. Even though you will hear a lot the subject that maybe transformers is the main architecture of all modern AI models, maybe something else is coming. 3 years passed, not really all the models, even though they adapt some additional layers of complexity, but still it's the same architecture, the same hardware, specialized hardware would easily work with all of those models. So that's what we did. We built transformer-based proof of work. It requires a lot of additional rethinking of transformers, of how to make them similar to hash when it's unhackable, and we invested a lot in that. And white paper about this subject is published on Gonka website. But also, you can't just occupy the compute with random numbers, as we see Bitcoin. Yes, Bitcoin computational network grew millions of times through the last 15 years, but no one uses compute rather than just for security sense of consensus. But proof of work can be redesigned to align the compute with the real tasks which developers will request through API, and that's why we call this sprint-based proof of work. So we create a transformer sprint-based proof of work, and this is the center of Gonka, and that combination of technology should enable this future when it will be super profitable for small research groups to rethink how the hardware should be designed and built. And we see already many great startups out there. Many, few of them are from crypto. They previously built mining equipment for Bitcoin or for Ethereum, and they are all right now rush to build a better hardware. So definitely this is what is needed, and then incentives, as you mentioned, should be aligned with that. So if you actually connect to the network better hardware which can produce like 10% more AI tasks, you should get 10% more of incentives, and it should be any gatekeeping. It should be permissionless, so that no one can just control the market, even though their hardware is not the best hardware, like we see with NVIDIA. You see all this announcements that Broadcom will build ASICs for AI, like specialized chips for AI, or NVIDIA will maybe do it in the future. But we've seen this in the past. They all tried to compete for Bitcoin mining, for example. Bitcoin mining was at some moment was a savior for NVIDIA. It actually increased their revenue significantly, but they entirely lost the market because they weren't able to innovate with the speed which crypto industry brings. And because of the accountability, you need every month someone will release better hardware, and you need to be fast. And also the idea is that even if you lose this race, you still win because you already mined the coin. So the coin will grow and you will still win. We really love the story of Bitfury. At some moments, they were the best hardware producers for Bitcoin mining. But because of the strange case when they produced the new series of hardware, and it was all broken somehow. So they lost the race, but have they actually lost it? No, because they were big miners of Bitcoin. They mined a lot of Bitcoins, so that with the network growth, they actually built their fortune out of it. So the same principle is really important with hardware innovation, because in hardware, you can lose everything just because someone will produce a better hardware. So we need this unique incentive mechanism which introduced by Bitcoin when yes, you can be early winner, but then you can lose, but still win, because just the growth of the network itself provide you with incentive in any case. We applied all of this for our network, as well as some more modern innovations like pricing model, which you mentioned, which we took as a combination from Bitcoin and what we see with gas pricing model for Ethereum. I think it's really beautiful, and it proved itself really well, and it should work greatly for AI compute market as well.
Absolutely. And yeah, it's great to hear that the team is taking the sprint-based, transformer-based proof of work approach. And in this way, it seems like it helps a lot to eliminate resource waste and make it so that a lot of the computational resources goes towards some AI-related tasks, those that are very relevant to the network, as opposed to those that are related to like network security. And yeah, interesting to see how having this hybrid model incorporating elements from mostly proof of work, but also some elements from proof of stake to this hybrid model can be really beneficial in this context. And also great to hear that we can avoid situations as well in terms of properly aligning the incentives so that those players would say like better, more optimized, or just more hardware in general aren't taking up all of the tasks in the network, and instead people who maybe smaller players but still have some compute to delegate, for example, can still contribute in a meaningful way. So it's great to hear that the team has considered like all of these factors all together.
Yes, it all works pretty nicely. You know, like when we only started, there was a concern that that what if most of the hardware which will join the network will be kind of low-end GPUs, which can't really contribute to AI compute. But still, we designed the system so that the better hardware you have, the more insensitive you get. That's what we see in the network right now, that most of the GPUs in the network are high-end GPUs, and they provide access to big models, and we really glad that it happened naturally. And still, there are big players who connected 150 GPUs as just one cluster, and there are smaller players who just rented out the GPUs on some GPU provider and connected to just one GPU or 8 GPUs to the network. And they all get incentive proportionally. So the fact that you're a smaller player doesn't mean that you excluded. You still can be good contributor to the network, and we're also glad to see that the incentive model also make it so that no one have too much power in the network. Like we don't have any player which accumulate more than 20% of the power, and in our case it's also voting power in the network. You know, like we got a lot of questions around, like, but what if someone will decide to add like 1,000 GPUs to the network and will try to conquer the network? But what we say is that at the same moment when someone will decide to add 1,000 GPUs, someone else will decide to add another 1,000 GPUs, and that's what we see in decentralized fields. That if incentives work properly, it naturally creates the honest majority in the consensus making. And we also see that because all these players, the miners, they run this hardware, so that we see quite good participation of the participant in the network development as well, in the way how network makes the upgrades and new development of the network, how different miners participate in this process, and it actually quite beautiful how it grows. And In many people, I think that many outsiders to blockchain fields see blockchain as chaos. It's really hard to agree and really hard to build consensus. The centralized players can move faster, but we see it differently. We actually see those networks emerge quite beautifully. They are super reliable because you will lose immediately if you miss some like block formation or things like that. Imagine like you don't have such punishments in any corporations. In corporations there is no accountability of this level. So even when servers will be down, like no one will be actually fired in those companies. Like AWS had outage today. No one will be fired. So like no one actually bears the real responsibility which every miner feel in the network. So they have their hardware and investments in this hardware on stake. And so we actually really enjoy to see how naturally those incentives and those protocols, how naturally it creates this beautiful network where everyone passionate about this idea that network will grow. And like they attach modern hardware, GPUs, but they all passionate about the fact that these GPUs will be obsolete and they all will need to replace it with ASICs as soon as possible. And they see it as a good side, while in centralized players, if a better ASICs will be released, they all will try to resist this because they just build a huge data center filled with Blackwells of NVIDIA. So yes, we do think that the industry already developed the framework. We just need to follow this properly. And yes, we need to adapt it for AI era. The hardware should be different, so the APIs should be different, and the throughput of the network should be different to support this. But we definitely, as a community, I'm quite hopeful that as a community we can build such beautiful systems.
Mm-hmm. Absolutely. And I really like your point also with the design, how it enforces not just the incentives, but also the accountability aspect that we don't see as much in the current companies that are really dominant today. And I also wanted to ask you about Gonka's approach for some edge cases, like mitigating the risks that come from, say, for example, dishonest nodes that will return, for example, a result that's not consistent with what should have been generated, or if some misinformation is inserted in the process. And I suppose this all ties into how Gonka approaches task verification as well. And I know that Gonka has some particular approaches with balancing verification costs without compromising trust, either with like majority verification or randomized task verification. But wanted to hear more about the approach for this verification aspect for mitigating any cases of dishonest nodes, and how Gonka really addresses the idea of trust here.
Yeah, so for us, it was clear that verification should be part of the protocol, and it should be job of every validator to participate. When you see projects like BitTensor, or you see other upcoming AI networks, usually the question of how it will be validated kind of put on the side. Someone else will decide it. It can't work like that. So verification is part of the protocol, And we designed it so that if you try to cheat, if you try to give a wrong answer on the request, or even to just quantize the model, so to try to make it cheaper for you, you will be caught and you will lose the rewards. You will be also slashed in terms of your future collateral and things like that. So it will be quite painful for you if you will try to do that. And it is job of every participant to participate in this process. But it doesn't mean that all of the participants should to check all the tasks. It is impossible. You will AI compute is already quite heavy. Like if you will try to multiply it in thousands, it won't work at all. So, but what is beautiful in Gonka, and what is beautiful about proof of work, because all our hardware nodes are actually weighted with proof of work, so they all have the share in the voting process. This create beautiful part of our protocol that when you decide whether you need to verify this task or not, you probabilistically multiply it on your weight. Which means that if you have, for example, 10% weight, you will only randomly verify every 10 tasks. But together, honest majority verify most of the tasks. And because we all know, like every single blockchain out there, every single consensus system is based, including Bitcoin. Read it in a Bitcoin white paper. It's really important that every such a system based on the idea that majority of participants are honest. And we only need to mitigate the attacks of dishonest minority. In our case, hardware providers can have this consensus because they have the weight. Like for example, in proof of stake systems, stakers have the weight, but hardware providers, they don't. That's why you cannot really use such an optimization. Without this optimization, it's really impossible to make any verification process which is efficient. And at the same time, we use the things like every participant generate a secret and share signature of this secret with everyone, but the secret is unknown, and the secret is used to decide which tasks you will verify. So I won't be able to predict which task you will verify, so that my probability to be caught is really high, and that's why I cannot collude and cannot expect that I can predict which of my tasks will not be verified. In the end of the cycle, you will uncover the secret, and as soon as you uncover the secret, everyone can check that you actually did your job. It's really important. You know, like what we've seen as a kind of bad lesson from the past for most of the systems, that we usually make consensus as a task which everyone should do, but the rest is volunteer, it is optional to do. That's why we have all these problems with indexers, because no one wants to be an indexer, and someone should finance indexers, and because of that, indexers are quite centralized in nature, and we don't have a solution for that. Or if you will try to actually connect your node to Ethereum, yes, you will see many participants on the staking chain, so-called beacon chain, but in the main chain, you will see only like 3-4 nodes. Imagine like network of $400 billion, and you will see really a small amount of participants out there ready to contribute. Why? Because your incentives are independent whether you contributed or not. In our case, it's not the case. If you don't, like every single part of the network, API you provide, verification, consensus, every single piece of it is your duty. If you miss your duty, you lose a reward. And only that can deliver robust system from all the dimensions which are important for AI. And it was quite a focus for us to make sure that every inference is verified, because it's also enable kind of the next evolution of blockchains. Like Bitcoin introduced immutable ledgers. It was really important that transaction cannot be stopped, cannot be altered. We can be all sure that if you make a transaction, it will be recorded. Then Ethereum introduced immutable contracts. Now we have smart contracts. We are sure that it will be executed exactly as it was planned, as it was designed. And now with the power of AI agents, when we actually can replace bureaucracy as a whole, and DAOs will be much more powerful when we vote, and then DAO actually can implement some complex tasks. So now we need agents to be also immutable. And the code execution part is there. The only missing part to enable that is immutable inference. And for that, we need to be sure that inference is exactly as it was planned by a person who uses particular model, that exactly this model will execute this task and no one will alter the output. So it was a long answer of like our true beliefs in verifiability, that it should be there. We know that more of the advancements of verifiability is coming with zero knowledge proof, with different advancement in hardware, confidential compute, and many more. But it should be part of the design, and it should be part of the incentive system. That if you are not participating in verification, you should be outed. You cannot be a validator of the system. You cannot be a staker who just get the rewards just because they put something on stake. No, you need to be contributor to the network, and in this case, we'll build an infrastructure which will surpass, which will be much bigger than whatever centralized players will be able to build in the next 5 years.
Absolutely, and really like the point that you mentioned that when we think about these different verification methods, those need to be really tied into the underlying incentive system that the design is based on. And yeah, I wanted to also hear more of your thoughts on some of the tools that you see could be achieved to scaling the verification aspect. Since this is a zero knowledge podcast, and you also briefly mentioned about potentially zero knowledge as well, just curious to hear about your thoughts on, for example, using ZK as a means to scalably verify some AI-based computation, whether that be with the inference level or even with the training aspect, perhaps in the future, the compute step or the outputs. Wanted to hear your thoughts on using ZK, if we're ready today, right now, to use it, or maybe this is something to think about more so in the future. I just wanted to hear, your thoughts about ZK or any other types of tools that you see could really help scale verification.
Yes, with AI compute, it is quite challenging because most of the developers use large models. Most of the developers right now use hundreds of billions of parameters models. ZK is not there, but it's moving in this direction. And what is beautiful about still Web3 and blockchain, that this type of long-term projects are possible, and they are financed by tokenomics of the projects which develop in the hardware. We cannot just rely on GPUs with ZK as well. We need to advance the hardware. We need to advance the algorithms for it to happen. So we follow most of the projects in the field, and we look forward to see those projects to enable zero-knowledge proof verification for AI. And I think that this will be important, and eventually this will be a solution. At the same time, we need to be fast. We need to deploy decentralized AI as soon as possible. Otherwise, generation of consumers, generation of end users will grow on non-verifiable, control, censored, and AI. So from this perspective, we see our role is in enabling this decentralized compute with the technologies which are available today. And we need to move fast. At the same time, we see great progress. We're already, some of the founders of those companies, they participated on your conference, and they already achieved really good results when smaller models are purely verifiable, and the performance of these algorithms are much better than even what we see half a year ago. We truly hope that this is coming, and that the projects are involved in these fields and community which you also built and gathered will solve this task, because eventually it's definitely solvable. We just need to invest more time and more attention for it to happen. In parallel, we need to build networks which will be powerful and which will allow us all thrive and build end-user products around decentralized AI compute networks. Yeah, so in general, it's really great that incentives allow us to develop this science further, allow us to develop needed hardware further. It's for sure needed for to finally solve this problem, and we hope that decentralized is in nature. Different projects are focused on different spectrums of what should be built. There are many projects out there, for example, which focused on training. So even though we enable training over the network, but we see that infrastructure of all the big AI companies growing because of the inference, because of the end user AI compute. So that's where we focus, but we see really beautiful projects which are more focused on training, and we see projects which are focused on solving zero-knowledge proof for AI. Contribution of all of us is really important for the final solution out there. For example, when Cosmos SDK introduced the latest version of their interchain bridge, they actually enabled bridge towards Ethereum, and they enabled it through a different zero-knowledge proof network. Most likely in the future, we will see similar stuff when projects which will be able to solve zero-knowledge proof will serve the rest of the industry, the rest of the ecosystem, to make verification even more reliable and cheaper. And at the same time, other projects will contribute more in bringing open source models, which not only will be open-weighted, but will be completely trained open source, so that we all can see what is inside and how they fine-tuned. And at the same time, we'll see projects like Gonka, who will contribute all their efforts in building this next generation infrastructure to enable all this um, models and to enable all these advancements of verification, so that we will see like our own Stargates, but Stargates not as just one building somewhere in the middle of Texas, but distribute around the world and being like really on the edge, having even better performance than anything which can be delivered by centralized networks.
Yeah, absolutely. And really love that vision again. And just as a last question before we close today's session, I'm curious what's coming up next for Gonka and how can anyone in the audience, for example, any developers who are more interested in learning more or using Gonka, how can they get involved?
Yeah, so first of all, please follow us, Gonka AI, on X, as well as join our Discord. You can find it on gonka.ai website. There we like building community of miners, developers, so you can actually be supported by the community. But also you can just look at the documentation. It's still like our threshold was quite high. We knew that we need to make as easy instruction as you would experience when you connect your apps to OpenAI API. So it is a reference for us. So we made everything possible for both miners and developers to have this experience when they can actually just go to documentation and do it by themselves, but also join the community and let's discuss together, let's make it better. If you have any hiccups on the journey of connecting to Gonka, contribute this to the community and we all together will make this project better and grow. For Gonka itself, currently the main goal is to grow the community, to grow amount of miners connected. We already just recently reached 700 GPUs. Imagine it's just like 6 weeks old project. So our TG was just recently, and we're already closer and closer to the scale of 10 billion worth of networks. And we see how miners community really love us because they all tried different other projects, but it's really hard to build something profitable when stakers mostly get the rewards. In our case, it's different. So we have early miners who mine Gonka coin just with like 2 cents in terms of the cost, which they incur by mining it. And some of them recently made an off-chain transaction selling this for more than 10 cents. So just in 6 weeks, like 5x growth, like it's impossible to earn this type of revenue from just leasing this equipment through Vast AI. So, usually when you hear about such projects, such networks, the main subject is, if you have spare GPU, which is unused, connected to the network, as if it's not really profitable. It's just like if you don't have any other use. But in our case, it's actually, I would say, it's the most potentially profitable way to actually generate revenue from your GPUs. So now, we're not targeted for spare GPUs. Put the spare GPUs to some project like Vesna. We need the GPUs which will be 100% time connected and which contribute to the network and who will see this great potential to actually generate the significant wealth. Right now it's 700 GPUs. I mentioned in 2011 it was 1,000 GPUs in Bitcoin network. Each GPU earned a lot. But this also will kind of, as the main pillar, it will be built on the fact that amount of GPUs will grow, and with the amount of GPUs grow, the underlying cost of mining coin will also grow. This is also important. Like when Bitenza network 6 or 9 months ago grew like several times in terms of GPU, we haven't seen the same type of growth of the coin, because nothing actually changes, whether it's like 6,000 GPUs or like 8,000 GPUs. In our case, because we have Bitcoin model, with the growth of amount of GPUs, each GPU get less coins, which entails that the underlying cost, like with excavation of gold, like it's harder and harder to excavate. That's why it's actually also form the expectations around the price. So when you see that the mining amount of GPUs grew in the network 5 times, it means something, and we hope to see like the community growth and the amount of GPUs in the network grow as well. This is kind of main focus. We expect that programmatically quite soon the trading also will be enabled. When the network was launched in Genesis, the transfers of the coins were prohibited for some time. That's why for traders there was nothing to do, only like for miners and developers. But actually, quite soon, follow the protocol, follow the social media as well. You will see that the trading will be enabled soon. So many more people will be able to join, not only people who are able to connect the GPUs, but also who are or people who develop apps, but also people who can just contribute by acquiring coins from miners. So that's kind of, I think, the main focus for the network right now. We're trying to follow this as well, trying to communicate with the entire community. Community decides most of the changes which could happen over the network, in community formed by miners. So people who really interested in making this infrastructure better and more efficient. So we hope that we also will be able to keep up with the rest of the community and contribute whatever we can in making these networks the largest networks in terms of compute power.
Great, and it's so impressive to see how much was accomplished, especially in the last 6 weeks for the Gonka team. And I know that you and your brother are working traveling a lot right now, and also meeting with different potential clients and partners. So there's quite a lot that is coming up right now for Gonka, and very excited, personally very excited to see. And thank you so much.
If you're also in Shanghai, we will travel tomorrow to Shanghai blockchain week. So would love to meet with everyone out there, as well as in Argentina later in November. So please find us and please connect to Discord and be part of the community.
Yeah, thank you, David. And I really appreciate you for coming on to today's podcast. And I think we covered quite a lot of topics, going from kind of the roots in one of the earlier projects that you created relating to distributed compute, and how those frameworks that you learned from there is really applied to what you're building today with Gonka, even with AI-related safety, the vision that you and the team have for that. And the 2 main areas or priorities that you're addressing with making the developer experience friendly and how to properly set incentives, making them aligned with the network, and how that's really informed some of the design considerations within Gonka. So I really enjoyed hearing about all of this, and not only just on how Gonka works, but kind of the origin story and the progression to where it got today. So really enjoyed hearing all of that, and thank you again, David, so much for coming on.
Thank you so much, Alice.
Yeah, thank you.